sustainability future. Before we get started, I'd like to introduce our guest speaker, Thomas Braillet. Thomas, the Solution Line Director, ArchiWizard and Sustainability. Thank you so much for joining us today, Thomas. I'll turn it over to you.
Hello and welcome to this webinar on sustainable AEC. Whether you're an architect, an engineer, or actually anyone working in the construction sector, you've come to the right place if you're interested in sustainable solutions for the AEC sector. Today, we're going to tackle this issue from a BIM perspective, and we'll see how BIM can unlock new possibilities to help you design and build more sustainable buildings. I'm very happy to have you all here, as I'm spearheading Greatex's line of product on this very topic of sustainable AEC. In a previous life, I worked at McKinsey, and I come from an engineering background. But without further ado, let's dive in. Before moving to the solutions, I think it's important we're all on the same page about the current situation. That's why I'll spend a bit of time and try to convince you it's as responsible to design and build as we used to in the last century. Once this context is established, I'll show you different remedies. You'll see that we're fully equipped to rise to the challenge of our century. And by the way, feel free to type your questions in the chat. I'll spare some time at the end to answer them to my best. First things first, the situation. There is no debate that the climate crisis is no longer looming. The greenhouse effect of some atmospheric gases was discovered as early as 1824, so 200 years ago, and it started to be quantified 4 years before the turn of the century. Not this 21st century, but the one before, by Arrhenius. And there's a famous memo to the US President Carter in 1977 on fossil fuel and climate change. So you can see it's a long-standing issue. It's not a novelty. And we are now fully sure that global heating is due to our activity as a species. We are driving it up, and the hypnotic spiraling graphs are showing the increase of CO2 concentration on the left and global temperature change in the middle. Currently, we're heading towards roughly 3 to 4 degrees Celsius of heating on average compared to pre-industrial times. And on average, I mean on average on Earth, but some places will actually see more than this, and also on average annually, as some extreme events will skyrocket to 5, 6, 7 degrees more than what we're used to. What does it mean? It actually means dire consequences. For example, half of mankind are under heat stress under an average of 4 degrees of increase. So heat stress is where you start to feel really uncomfortable. You start to be at risk of dying because you're overheating in your corporal body temperature. And as AXA's CEO said around 10 years ago, a 2-degree world might be insurable, but a 4 degrees world certainly would not be. So it has huge consequences on assets, real estate assets, because it also has other consequences on sea levels, for example. But sustainability is about planet boundaries. It's not only about greenhouse gases. Earth is actually now well outside of the space, the safe operating space for humanity. Because we're pushing our environment to its limit in many aspects. It can be about water consumption, resource utilization, obviously climate change with greenhouse gases. But overall, 6 of the 9 boundaries are transgressed, and a 7th one is close to being breached as well. Pressure is actually increasing on all boundary processes except ozone depletion. And the building sector bears a major responsibility, as you can see on the slide. The building sector is a major energy consumer. Around a third of global final energy consumption is coming from the building and construction sector overall on Earth. And more than a fifth, so 21% of greenhouse gases emissions come from the building and construction sector. So we have a major responsibility on this crisis. Another example is about resources. The second most material used on Earth is actually concrete. To give you some idea, more of an order of magnitude, we are using 4 times more cement in these years around 2020 than we were using in 1980. This represents around 18 kilograms of sand per person per day on average on Earth. So you can start to feel how much material we're using in the building and construction industry. The thing is, we as an industry, and I mean the AEC sector, we need to reduce our GHG emissions, so greenhouse gases emissions, and our overall environmental impacts, which means we need to do better, we need to do differently, we need to build differently. But we also need to build differently in another way. Newly erected buildings need to withstand extreme thermal conditions as they need to be future-proof. We spoke about the temperature increase. It's thus not only a matter of mitigation, so mitigate climate change by reducing emissions, but also a matter of adaptation. Now, what can we concretely do? And I don't intend any pun here. Well, it happens that BIM can clearly help, and let me show you how. For this, the objectives are actually quite clear. We need to build less, but also to build smarter. So to build less, we need to question the need. Do we really need to erect a fully new building here of this size and this area on the floor, for example? Could we refurbish or repurpose another existing buildings instead, for example? Can we reuse some materials? Can we reuse even some floors, some rooms, some furniture? So this is about performing the same level of results, achieving the same results by using less, building less. We also need to build smarter. So we need to build for longevity. So the building is some kind of investment, obviously from a financial point of view, but also from an environmental point of view. And the more we can use a building, the more we can amortize this investment over time, which is why we need to build for longevity. At the same time, we need to build efficiently. Efficiently, it can be about carbon, so lowering carbon intensity per square meter, for example, by using certain types of materials, but also about energy efficiency with insulation or other techniques, and also resource intensity. We spoke about sand earlier, but also water is a huge matter, metals as well, and every kind of resource, actually. For this, we can apply existing principles, and I'm not going to dive into each, but this non-exhaustive list of principles provides you with some examples, sometimes obvious, but always good to keep in mind. Clean equipment is an easy one. Of course, a heating pump will be more efficient carbon-wise than an oil burner working on heating oil, for example. That's why, by the way, it's not banned in France. Compacity is easily understood as well, obviously. The more external surface you offer, the more heat you lose in the winter. For a given volume or floor area, the less efficient you'll be. So compacity is measuring this exactly, geometrically speaking. Multifunctionality of spaces is about using modularity in the design or compatibility right from the start. If the building needs to be repurposed in the future, it's already planned in some way. Now let's zoom on a couple of topics with BIM. You can see on the picture a weird looking house, and Eric Vassar built this weird looking house by studying sundials, actually. The objective here is to harness free energy from the sun in the winter when it's low on the horizon, even at midday, while staying protected in the summer so as not to overheat. How can you achieve both with such a weird looking geometry? How do you do without studying sundials with BIM? So based on the 3D model and also walls compositions and all such BIM data, you can simulate these various effects I just spoke about. On the picture, you're seeing the amount of energy received from the sun, accounting obviously for indirect bounces and so on. This picture provides you with a very intuitive visual tool to properly optimize your window openings, your sun shields, and so on and so on. And all of this is happening in a BIM software. So too long of a sun shield and you'll need to heat more in the winter. Too short and you'll overheat in the summer. Such a software can simulate how many hours exceed a certain temperature over the typical year, so you can iterate on the choices of material, sun shields, and so on. If you remember mitigation and adaptation, this is exactly it. Energy performance together with summer comfort. All right, let's move to another principle. Optimization of material choices is another principle that can be enabled by BIM. How do you do this? With a tool named lifecycle analysis. It's more of a methodology than a tool, so LCA. LCA is measuring environmental indicators such as climate change, so greenhouse gases emissions, ozone depletion, acidification, water use, and so on and so on. And this measurement of those indicators, this analysis is conducting by the supplier of the material according to specific methodologies and hypotheses, and then is certified. It can also be done at aggregated level for standard average materials like this average concrete produced in France, and it gives you an order of magnitude of, for example, the greenhouse effect of 1 kilogram of 1 ton of this kind of concrete. Some are collecting data on the cradle to gate stages, so the product stage. Some on upfront carbon, so product but also construction, and some on cradle to grave stages, which is everything except module D, the reuse or recycling. Some are collecting data on unbodied carbon, so the same without the operational part in the middle, so B6 and B7. Of course, the quality of the inventory data determines the credibility of the results, and that's why it's such a standardized, certified thing. This analysis has results. It has an output, which is an environmental product declaration, EPD. And all those EPDs are stored into databases. So INES in France is the official one. EC3 is another one. For example, there are over 16,000 EPDs recorded that are verified in the European standard, and then 90,000 more in the ISO standard, though most ISO EPD are on concrete. It's actually a growing trend due to label certifications, and in some countries like France or some Nordics, due to regulation. And this explains why a third of ENEPD comes from the French, so the black part on the graph. As always with data, there is the question of quality, so it needs to be findable and accessible, interoperable, and comparable. So you need to be able to compare these values, this numerical value for this product to another numerical value for another product. It needs to be around the same methodology, the same kind of measurement. But there is a lot of progress in the field about this. If you remember mitigation and adaptation, they can be conflicting goals. I need to better adapt to future climate, but it can represent more carbon budgets now, for example. And on top of carbon, there is energy performance, there is hygrothermal comfort in regard to humidity and temperature at the same time. So you can see it's a multi-criteria optimization that is encompassing the building envelope and the choice of materials. And this is where BIM comes in. So with the BIM software, you can inform your design and your decisions in regard to all those criteria. So you can check if you replace this kind of material in your wall compositions by this other one, how it's going to impact your carbon footprint for the building, how it's going to impact the summer comfort, how it's going to impact the energy performance, all at the same time. And also access to natural light if you're using sun shields and so on and so on. Because using sun shield means better protection in the summer, but more materials that are being used to create this horizontal things. So this is where BIMs come in, where you can see the impact together for all those criteria. You can iterate very easily to converge to an optimized solution that you're simulating beforehand, and you can then certify it according to different label certifications or regulations, of course. Here you're seeing the composition of the wall in the middle that is applied to all the red walls on the 3D model. And this is where you can apply a different wall composition, and all the indicators can then update and give you a better understanding if you're doing a good job towards this or this indicator, or if you need to further iterate. Last but not least, the accurate sizing of equipment. It's obviously a huge principle, and again, BIM can be an enabler of this. So based on the building envelope that you're taking from the BIM model, and also on the other hand, based on peak weather and also set point of temperature you want to live in the building, you can simulate the different energy needs of the building for this climate in this location. And again, the BIM software is here to inform your decisions. So you can select this temperature, and again, you can select a projection of the temperatures in 2050 or 2080 to see where you stand against future climates. Again, it's always a question of mitigation, using less energy now, emitting less carbon now, but also a question of adaptation, how you're going to do in 30 years in this very building. And BIM software is here to simulate all these phenomena, and then to help you size accurately your equipment that you're going to need for aircon, for example, or for the boilers, for example. I hope this webinar was informative and helped you, one, better understand what's at stake, Two, why it's important to tackle this issue of sustainability in the AEC sector, be it on mitigation or adaptation. And three, most of all, discover how BIM tools are great to inform your designs and construction methods on the matter. Feel free to type any questions as we have a Q&A. If not, have a good day and enjoy the other Innovate to Build webinars. There's another one specifically on thermal comfort, so go check it out.
Wow, 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 wow. Feel free to ask your question in the live chat. Thomas will be there. Thomas, we are waiting for you.
Yeah. I just read a couple of questions that Corinne received directly. Quite good question. Consideration of the climate impact for renovation. Of course, all that was said can clearly apply both for new buildings and also for retrofit or renovation of existing buildings. Maybe the only difference is that for renovation, you'll have to start with the baseline. So you first have to assess the current building from a climate point of view, like the energy efficiency of the envelope and the equipment, but also from a carbon point of view. And then you'll start to build a couple of scenarios, and then you'll be able to pick the best scenario that gives you a good compromise between optimization against climate change, both from a mitigation and an adaptation point of view, but also the costs. And this relates to the other question, how do you consider reconstruction costs? A lot of industrial companies are making a lot of effort and a lot of investment in this field to improve their material, for example, and to help you design more sustainable building for marginally higher costs. So it really depends on each case, obviously. But for sure, you have some low-hanging fruits, let's say, and for roughly the same costs, like maybe +2, +3, +5%, you'll be able to build a better building, a more sustainable building. It's mainly coming from the choice of material and the choice of equipment. But as you all know, the cost of a project does not only come from the choice of material and the equipment. It's also all the time that is spent by everyone on the field to actually build the building. And I didn't mention these areas and these examples, but off-site construction can be an answer to this, as most of the time it improves the time to construction, but it can also greatly improve the climate impact. So you can have the best of both worlds, for sure. Let me read the other question for everyone. How do we consider availability of material currently in specific area for a specific project? If you're speaking about the carbon aspect, the specific area is basically modeled in a way in the life cycle analysis. So the transportation is taken into account. But of course, in the real life on your projects, you can choose material A, and then you you realize when you have to actually launch the construction of your projects that it's not in stock, it's not available by the manufacturer, and you have to find material B or an equivalent material of material A just right now on the spot. And this leads me to something that I didn't speak about because obviously we always have limited time, but you can perform the life cycle analysis at different stages of the project. And it's best to first do a rough estimate of the carbon impact at the pre-design stage, like the early stage of the design. Then do a second one, which is going to be more precise because you have a better idea of your building and also the recommendation of about the cost and the different options. So you do a second one at the technical stage, technical design, and then when the construction is starting, you can do a third one. And once the construction is finished, you can do a fourth one, which is going to be the final one with what you actually used in the real world for this project, accounting for whatever mishappening that can happen in real life, like material availability for this project, for this area, for example. And again, this is where BIM is really valuable. If you're not using BIM for this, it means you're going to do the lifecycle analysis manually. So you'll have to update everything, I don't know, in Excel sheets or stuff like this, which is going to be really, really painful. If you're relying on BIM, you can just in the different in the software I provided screenshots of, you can just synchronize with the 3D model and the BIM model, and then the geometry is gonna update in the environmental software. So it can be really fast to just iterate on your model and then check the impact on the choice of material, the different architectural choice of your building. And again, if you update the materials, if you have the list of materials, and because there is no availability for this specific area, and you're going to use material B, you can play with the different materials and update this and this and this material and just launch the calculation, which is really fast, and checked the impact. And again, if material A is not available, you can have different scenarios. Okay, do I choose material B or C or D? And what is the impact both on the carbon but also on the other aspects of the environment, like the energy efficiency, obviously, because if you're going to choose a material which is less carbon emissive, maybe you're going to degrade the insulation of your building. So you have to check the different criteria at the same time. And again, this is where BIM is really valuable. Feel free to tell me if you want more detail or if you feel I didn't exactly answer your questions. And of course, drop more questions if anything comes to your mind. Maybe if you can tell how you're taking into account these sustainability issues in your projects currently, it can be quite helpful to the roughly 100 people who are connected live at the moment, just to check how everyone is doing on this, if how far in this journey you are, if you're already using such tools or not, if you don't have this kind of demand from the people asking for the projects. For sure, it depends a lot on the countries. Some countries are starting to put forward regulations and some laws on the construction projects. In other places, it's going to be more voluntary. So it's going to rely on certification schemes like BIM or LEED, for example. But if you check the number of certified projects by BIM or LEED, it's been skyrocketing for at least 5 years. It's really taking up, and also the different regulations are spreading across the countries, across the earth, let's say. California recently passed a new law, not only on energy, but also on carbon. Greater London has one as well. Obviously, France, I mentioned it, that France has something that applies to any new building, regardless of the size, regardless of the type of the building, an office, a dwelling, an individual house, or a collective dwelling. And more countries are following up and are at least discussing or putting forward such regulations.
Okay. Thank you so much, Thomas. If there is no more question, I do want to thank you, Thomas, for joining us for Innovate to Build, and also want to thank everyone who was attending to today's session. We hope it was meaningful and impactful for you and sure for your business. Thank you all and have a wonderful rest of the day. Bye-bye.
Thank you, everyone. And feel free to check the other sessions. There are more detailed sessions on sustainability during these 2 days of Innovate to Build. So it can be great if you check some more details on how you can implement these principles in your daily projects. Have a great day, and thanks, everyone.